In this lecture video, we'll learn how to calculate probability. Let's take a look at the example of being dealt a 5-card poker hand. What's the probability of being dealt 4 aces? In order to calculate the probability of 4 aces, we need to know the number of ways this is possible and divide that by the total number of possibilities. Let's consider how many ways we could be dealt 4 aces. We'll first consider this intuitively. If we're being dealt 5 cards and we want 4 of them to be aces, there's really only one choice for 4 of the cards in our hand. This leaves 48 other cards in the deck that we could have for our 5th card. So simply looking at this intuitively and using the multiplication property, we find that there's 48 different ways to be dealt 4 aces. Let's also consider this in terms of combinations. With our first 4 cards, there's 4 aces to choose from, and we want all 4. So we could consider this to be 4 choose 4. And with our 5th card, there's 48 cards in the deck to choose from, and we simply want to choose one of them. If you have 4 cards, how many different ways can you choose all 4 of them? There's only one. And if there's 48 cards, how many different ways could you choose one? 48. So whether you think of this intuitively or in terms of combinations, there's 48 possible ways to be dealt 4 aces. Now that we know the numerator is 48, or the total number of ways to be dealt 4 aces, let's consider the denominator. We can calculate the total number of possible hands by using combinations. With 52 cards in a deck and choosing 5 of them, we could use 52C5 to calculate the total possibilities, which is 2,598,960. Dividing, we find that the probability of being dealt 4 aces is 0.00018. Or in scientific notation, this is equal to 1.8 times 10 to the -5th. What we've just done here is an example of a probability assignment. A probability assignment is a function that assigns each event a number or a probability between 0 and 1. If an event is impossible, then its probability is 0. And if an event is certain to happen, then its probability is 1. Now let's switch from poker hands to rolling dice. Let's first calculate the probability of rolling a 2. Remember that we calculate probability by taking the number of ways that that event can happen and dividing by the total number of possibilities. How many different ways can we roll a 2? That's how many different ways can the dots on the dice add up to 2. There's only one way that can happen. That's if both dice are aces, or each have a single dot. So this event only has one outcome, and that's the outcome where both dice are equal to 1. So the probability of rolling a 2 is equal to 1, the number of ways that can happen, divided by the total number of possibilities, or 36. So the probability of rolling a 2 is 1 in 36, or approximately 0.0278. Now let's consider the probability of rolling a 3. That's the 2 dice having a sum total of 3. This time there's a couple of different ways we can add up to 3. The first dice could be a 1 while the second one is a 2, or the first could be a 2 while the second is a 1. So this event has the 2 outcomes of 1, 2 and 2, 1. The probability of rolling a 3 is equal to the number of ways that we can roll a 3, which we know is 2, divided by the total number of possibilities, 36. So the probability of rolling a 3 is 1 out of 18, or approximately 0.0556. Last, let's calculate the probability of rolling a 4. We have a few options this time. The first dice could be a 1 while the second is a 3, or the reverse. The first dice could be a 3 while the second is a 1. Or finally, they could both be 2s. This event has 3 outcomes, 1, 3, 3, 1, and 2, 2. So the probability of rolling a 4 is equal to 3 out of 36, or 1 over 12. This is approximately equal to 0.0833. Now let's look at some slightly different probability questions. First, what's the probability of rolling at least one ace? The key words here are at least one. We could roll one ace, or we could roll two. Let's start by listing out all outcomes in the event of rolling at least one ace. The outcomes are 1-1, 1-2, 1-3, 1-4, 1-5, 1-6, 2-1, 3-1, 4-1, 5-1, and 6-1. So we find there's 11 different outcomes for the event of rolling at least one ace. Now let's calculate the probability of rolling at least one ace. The probability of rolling at least one ace is equal to the number of ways that we can roll at least one ace, which we found to be 11, divided by the total number of possibilities, 36. So the probability is 11 out of 36, or approximately 0.3056. Now let's think about the probability of not rolling an ace. In this example, the key word is not. Notice that not rolling an ace is the exact opposite of rolling at least one ace. There are no other options. We either roll at least one or we roll none. So the outcomes of not rolling an ace are everything else, or all other options. So out of the 36, taking out the 11 outcomes that have an ace, there's 25 ways to not roll an ace. So the probability of not rolling an ace is equal to 25 out of 36, or approximately 0.6944. This is an example of complementary events. Complementary events are two events that are negations of each other. If one event is E, then the other one is not E, or the opposite. And that concludes this lecture video on calculating probability.